Now that we've covered some specific attacks, the book switches gears and talks about the TCP/IP protocol suite and explains what some of the different components are and where these attacks happen to fit in. The section entitled Working with the TCP/IP suite should actually be review for you. When we talk about TCP/IP, we pretty much group that into 4 discrete layers. At the top layer, closest to the user, is the application layer. Below that is the host-to-host layer. Below that is the internet layer where the packets actually get routed, and then below that is the network layer. At the application layer, we've got a whole bunch of different protocols that you ought to be familiar with. HTTP we use with web pages, that uses port 80, and if you're using secure HTTP traffic, that's going to run on port 443. File transfer protocol is not used as much these days. It's not terribly secure, but that uses ports 20 and 21. Simple mail transfer protocol uses port 25, and you're going to use that anytime you are sending email out on the internet. Telnet, golly, I think that uses port 23. That is a command line utility that you can use to actually check a lot of your higher level application protocols, just to make sure that you can establish a connection over a given port. DNS runs on port 53. This is what resolves host names or URLs to IP addresses. SNMP is a way that you can manage devices. With management software in place, it'll generate SNMP packets that will give some sort of a host or a repository information about the status of given hardware devices. Post Office Protocol, or POP, normally POP3 is the version that people use. That runs on port 110, and this is mail retrieval, where you pull emails from your email server down to a client. With POP3, the data is actually transferred from the host down to the client. There's an alternative to that called IMAP. With IMAP, it's still a mail retrieval, but the email stays on the host, and all you get is a copy of that. There is a note that I think is pretty important. It says one of the key things is to know what you're running, know what ports are being used, and then turn off unneeded ports. Servers are getting better in terms of operating system security. It used to be that, like if you look at a server 2000, there were tons of ports that were left open, a lot of security vulnerabilities. That got better in server 2003, and server 2008 actually kind of turned the tide. There's a lot that's turned off in 08, and then you have to go back in and enable that. Moving down from the app layer, we're talking about the host-to-host or the transport layer. The 2 big protocols that we run here are either TCP or UDP. The difference between the two is that TCP is connection-oriented, so there's actually checking between the host and the client, or the source and the destination, to make sure that the packet actually got there. They're sequentially numbered. If something arrives either out of order or does not arrive correctly, then the protocol has built-in triggers so that you either resend that packet or you regenerate the transmission. UDP, on the other hand, is connectionless, and you use that for things that don't matter. Things like DHCP requests. If you are trying to grab a DHCP address and you don't get it, well, the worst thing that happens is you reinitiate the sequence. Another example of this is real audio streaming. If you're listening to ESPN or anything over maybe internet radio, if you miss a packet or the packet gets out of order, nobody's going to go back and fix that. Those are examples of the UDP protocol. Moving down to the internet layer, here we're talking about actually getting these packets from one destination to the other. When I was talking about IP spoofing earlier, this is where you would do that spoofing. You would take the internet layer packet, which has the IP addresses, either the source or the destination, and that's where you'd go in and monkey around with that. A couple of other protocols that run at the internet layer. The address resolution protocol, ARP, is used for resolving IP addresses back to MAC addresses. ICMP is a protocol that runs at the internet layer, and so if you're running pings of death, that's going to come through at that particular layer. The lowest level is the network interface layer, and that actually gets your packets out onto the network. I assume that you've got lots of information about this, so I don't think I really need to give you a whole lot more, especially on the network layer. Moving on, the book talks next about encapsulation, and they've got a really nice diagram that I think is pretty helpful in understanding the process here. You start at the application level and you've got some data that you want to send maybe back to a server. At the application layer, the software builds whatever the data packet is. Then it passes it down to the transport layer, where it's either packaged as a UDP packet or a TCP packet. And you can see in the diagram we've got the application data that is then appended to the TCP/IP header. You move it down to the internet layer, and here's where we add the addressing. So we've got the application data with the protocol, the TCP or the UDP. And then on top of that we've got the IP information, and then finally we hit the hardware. When the packet is all together, we transmit it, put it on the wire, and then the recipient picks it up. And then we go through the reverse process. We take it from the network layer, move it to the IP layer. Here we check to make sure that we've got the right source and destination IP addresses. Then we move it up to the next layer. I keep looking at this diagram saying application, but we're going to move it up to the transport layer and do whatever sequence checking we need to do. And then finally we move it up to our application, where it'll either play as blurb on our internet radio or it will update our banking information. As a follow-up to this discussion, there's a section on well-known ports. You will be tested on the ports that are listed here. I think that this is something that all network people need to know. So these are pretty standard ports, and you should be comfortable knowing what the port numbers are and what the associated protocol is that you're using. Continuing with our discussion on TCP/IP, the next thing that the book talks about is specific to TCP/IP, and this is how you establish or end a connection. The three-way handshake is a series of transmissions between a client and a host, and essentially what happens is the client initiates a TCP/IP session and it sends a package to the server. That client includes something called a sequence number, and it also has a window size pretty much that says how big the data packets are that we're going to work with. The server is going to receive that. It's going to send a sync back and an acknowledgement that says, okay, yep, I got your window size, and here is the sequence number that we're going to use. At that point, there's an acknowledgement that's sent back, and there's a session that's established between the host and the client. Essentially what happens is with these sequence numbers, and the book calls it an initial sequence number, an ISN, those sequence numbers are going to be unique for each session. And so even though we might have a whole bunch of web requests from different users hitting a server, those requests are all going to have a different sequence number from each client, and so you can handle multiple connections. As long as you can keep those sequence numbers straight, you're going to be fine. We're going to move on to the section on recognizing TCP/IP attacks. The book is pretty straightforward here. Attacks can occur at any layer, even though most of the attacks happen to come in at the internet protocol layer, but any one of the layers has the potential to be exposed. In the section entitled Recognizing TCP/IP Attacks, the book pretty much states that out of those four layers, the TCP, UDP layer, and the IP layer are the two that are most susceptible to attack. It is possible, though, at the application layer and down at the network layer to be compromised as well. A couple of things to look out for in TCP/IP. Number one is sniffing, and you can either have a dedicated device that you put on the network, or you can just enable your network card to run in what's called promiscuous mode. In either instance, essentially what you have is a device on the network that is listening for everything, and it records anything that passes by. There is software that can identify if you have network cards or devices that are running in promiscuous mode, and so that is a reasonable thing to have on your network and run that at different times. Obviously that's dependent on your level of security. You're probably not going to do that all the time, but that is something to kind of keep in mind. Port scans are something that you will see very frequently from the internet going to your router or to your firewall. There's a check to see what ports are open on the router, because if a port's open, that means you can possibly get through the router in on that port and then get into a server. Most of the, in fact, all of the routers that that I monitor and that I run, I get reports pretty frequently that tell me about port scans. And these are just, you can buy, there's free software where you can just run these against a particular IP address, and it'll just check common ports, or you can tell it what ports you're interested in, and it'll just check to see if it can open up those ports. You can do this manually with the telnet command as well. What you're looking for there is something that's open, a way that you can exploit. The book goes on to talk about the TCP three-way handshake, and this is a critical component of establishing any TCP session. Essentially what you have is a client and a server, or in the case of the example, the figure they've got is host A and host B. Host A wants to initiate a session, so it sends a sync packet over to the server. The server receives it, sends back its own sync packet along with an acknowledgement. The client then completes the initiation by sending an acknowledgement package back to the server. So we've gone from client to server, server to client, and then client back to server, and at this point the connections and the session is established and you can go back and forth with your real data. Now this is important because a couple of the TCP/IP attacks that we're going to talk about in just a second deal with messing around with this particular sequence. However, before we get to that, there are a couple of things that the book talks about that are good to watch out for. The first thing that you should look out for is packet sniffers, and these can be standalone devices that you insert into a network. You just plug it into any open Cat5 connection. It acts as a promiscuous mode network card. It pretty much listens to all the traffic and then just packages it, sends it off to software, to a hard drive, and so it essentially records that information. This can, like I said, it can either be a device or it can be a network card on a box that's running in promiscuous mode. There is software that you can run on your server that will go out and check each card to see if any are running in promiscuous mode. When you get that report back, if you see one that is running in that mode, then you need to check it out and find out what it's doing, because under normal network operation you're not going to have that in place. The second thing that the book talks about here under recognizing attacks is port scanning. Sometimes you'll see this inside a network. Most often what you're going to do is see this from the internet going to a router, and behind that router is some sort of a private network. What you're doing with a port scan is you're just checking to see what TCP ports are open. If you try and connect on port 80 and you get a response back, then you know that, number one, they've probably got a web server back there, but you also know that port 80 traffic is going to go through that router. Same thing with POP3. Any of the ports that we've talked about, you can try a telnet session with that port to see if there's software listening for that and if that will open up a connection back to you. You can get free port scanners from all sorts of places. You can input the IP address that you want to go test. There's going to be a standard set of ports, well-known ports, that are going to be scanned, or you can specify whatever ports you want to have open or you want to have checked. Most firewalls, in fact all the routers and firewall appliances that I have, routinely tell me about possible port scans. Pretty much after I think 4 or 5 ports have been attempted, it just drops that connection.